Our retina has two different types of photoreceptors. We have the rods, and I'm going to leave a little space here, and then we have the cones. And they're called rods and cones based upon their shape. So if we look at a diagram of this, the rods are rod shaped like that, and then the cones have more of a cone shape to them. The rods are actually more numerous. So these are more numerous overall. They also are responsible for black and white vision. They also are more sensitive to low levels of light. When we look at the cones, these are more concentrated in the center of the retina, as opposed to the peripheral. There's more rods in the peripheral vision. And they are responsible for color vision, and they are less sensitive to low levels of light. So let's talk about this level of light. You probably have experienced that if you dim the lights in a room, the color kind of drains out of the room. Or if the sun starts to go down, all the color starts to go away and it becomes dusk. And you start to see in gray and white, black and white vision. And that is because that under low levels of light, the light is not stimulating the cones, it's stimulating the rods. And so the rods allow us to see in low levels of light. When we talk about that there are more rods in the peripheral vision, that can be useful when you're looking at the stars, because oftentimes if you're looking straight at a celestial body that's shining and it's dim, you won't be able to see it. But if you look at it outside of your peripheral vision, if you look at the star in your peripheral vision, because there's more rods on your periphery, then you will be able to see it. It's kind of interesting if you ever take an astronomy class, for example. Okay, so the other interesting thing about these rods and cones is that they differ depending upon whether the number of them differ depending upon whether you are a diurnal or whether you're daytime active, like birds can see very well in color vision, whereas cats are actually nocturnal and cannot see very well in color vision. So it kind of explains the difference in the ability to perceive color in different organisms. Now, if we look at where these are located in the retina, our retina is very bizarrely designed or arranged in that the light is coming in this direction right here. And so what happens when light comes in this direction is it has to travel through all of this nervous tissue that is out front. So the cones are kind of in the back of the layer, located near the vascular layer. And then all of the wiring is coming out the front. That is kind of a weird way to arrange things. It's different when we look at the eye of a squid or an octopus. The photoreceptors are right out front and all the wires are in the back. So it's kind of an interesting observation, the way that the retina is constructed. Here you can see, this is an electron microscope picture of the actual rods and cones. And you'll notice that there are just more rods than there are cones. Now, if we look at the cones, there are 3 different types of cones. So there is red cones, there are green cones, and there are blue cones. Some people are born genetically with a mutation that doesn't allow them to detect the difference between red and green. And so they either don't have the red or they don't have the green cones. And so there is no ability to perceive the difference between red and green. Um, and then some people are born where they only have, like, for example, blue cones, and then they would have totally black and white vision. So they wouldn't be actually able to see color. So that color blindness has to do with the ability to generate these different types of cones, which we're going to talk about what are the pigments that absorb the light energy. So that will be in the next lecture.